Okay, I'm going to walk you through solving dihybrid crosses and probability worksheet. So I've got some things already pre-filled. So number one, we're going to look at fox, the color of the coat, and how long the hair is. So for the symbols, the red is the dominant and silver is the recessive, short is the dominant, long is the recessive. So to make the parents, and this is really crucial, if you don't have the parents set up correctly, then everything from here on will not be. So just double check, triple check your parents. So the first one is pure red, so that tells me it's homozygous and dominant in this case, so 2 capital R's. Then long hair, the only way I can have long hair is it has to be homozygous recessive, which is right there, okay? Then I have heterozygous red, so I have big R, little r, and then it says short. Well, since I'm not sure if it's the heterozygous or the homozygous dominant, I use this term and it applies for everything after it. So therefore it is heterozygous too. Okay? Now I'm going to make my gametes, and you're going to use FOIL. Another way you can look at it is going first, third, first, last, second, third, second, last. So my first one, first, third, so big R, little h. And be consistent. If you write the R's first, do that in all of the gametes, whether it's capitalized or not. This is the only exception. My second gamete is first, last, or first, fourth. So I've got big R, little h again. Second, third, the same. And second, last. Now that one just happens to be all the same. Now this one's not that case. So here I've got first, third, first, last, and you notice that it's taking one allele of each trait and recombining them. Second, third, second, last. And notice I kept the R in front because I was consistent, even though that's my dominant allele. Okay, that's the only time it does that. Okay, so now let me move my gametes down, and it doesn't matter which side you go on. Just be consistent that if all 4 of these gametes will either go across the top or down the side, don't intermix them. Okay, so let me write these down real quick. Being careful to write the correct order, that's why I put circles around them, but you do not have to. Okay, now we're going to recombine the traits, and dominant letter first. That's going to be helpful later. So big R, big H, little h. Now since these are all the same, I can just draw an arrow to save myself some time. But remember to count those whenever you go to answer your questions. Then I'm going to combine these. Big R, little h, the same. Big R, big H, little h, the same. And then big R, little h, the same. Okay, so now let's look at the ratios. The genotypic ratio, we're going to look at all 4 letters. So there are only 4 that have this combination. So that's 4. Big R, little h. Well, there's no other like that. So that's 4. And that one's 4. And that one's 4. Okay, so my ratio is 4. That should be a dot. There we go. 4, 4, 4. Okay, those are dots and not exclamation points. So that should equal 16. Now you can reduce it. For this worksheet, I asked that you did not reduce it so that I can see that you understood the numbers. Okay, now the phenotypic ratio, pheno, first letter, physical characteristic. So that's why I put my dominant first. So here's one trait, the capital R, and here's my second trait. I'm going to move this up so I can see my scale here. Okay, so big R is red, and then the capital H is short. And if I go through, I know I've got 4 here. Let's see, that's a big R, little h. Oh, here's another one, big R, big H. So there's 4 there. So there's 8 that have that combination. Next, I have red, and then little h is long. And if I go with the combination big R, little h, I have 8 for that one. So my phenotypic ratio is 8 to 8, and that equals 16. But you may have another class where you'll be asked to reduce that. Okay, so that's number 1. Number 2, now we're looking at watermelons, and we've got green and striped. Green is dominant, round and long, and round is dominant. So my first watermelon, heterozygous green, big G, little g, round, and so that term applies for both, so big R, little r. It's going to be crossed with homozygous recessive for color, so that's going to be 2 little g's, as is represented right there, and then homozygous dominant for shape. I'm going to make my gametes, so I'm going to go first, third, first, last, second, third, second, last. And I'll do the same thing over here. Well, they're all going to be the same. So that's going to save me some time when I do my Punnett square. Then I'm going to transfer the gametes, one circle into each. Even though I'm drawing arrows, I still like to at least write my gametes into my Punnett square. Okay, then I'm going to recombine. So I'm going to start with my G's, so capital G, lowercase g, and then 2 capital R's, and these are all the same, so I can draw an arrow down. Then I have big G, big R, little r, all the same. 2 little g's, 2 big R's, all the same. 2 little g's, big R, little r, all the same. Okay, now let me see what my question is. Okay, my question is, it just wants my phenotypes, no ratios, none of that. So let me see what they're going to look like here. So first letter of each, I don't even need to worry about genotypes. It doesn't ask for that. So capital letter, so if you need to, draw a line, so you know that's one trait, that's another trait. So I've got big G is green. Okay. Notice I'm writing it out. I'm not using symbols because you can always change symbols and they may not be the same. Even though some symbols we use continuously, problem to problem, like height, we usually use T. Okay, and then I have a capital R, and that's a round. Okay, and then, so that's one possibility. So green and round occurring together. So I should have actually written it down here. Green, round. You don't separate these out because they're occurring together. So I've got 8. Then my next one is the little g is striped. And then the big R is going to be round. And then with that combination, now it doesn't matter what's going on with this second and last letter because I'm just worried about the phenotype. So anything with that combination on the first and third letter is going to be striped and round. So in this case, that equals 16. I don't write it in ratio format. It does not ask for it, but it would be an 8 to 8. So that's number 2. Okay, let's go ahead and do number 3. This one is on probability, and there was a short little 4.5-minute video talking about this, giving an example. So we're going to see here that we have a dominant trait of yellow, and that's dominant. And you don't need to write all of this out. You just provide the numbers in the formula. And so that's going to come out 450 times. And then the recessive trait green is going to show itself 122 times. Okay, and then it wants to know the probability of the recessive trait. So we're looking for the recessive trait. Okay, so, and it's the probability of it appearing. So you would not just write 122. So it's going to be 122 divided by, now I know you may be tempted just to put 450, that's the only other number left, but you need to take into account all of the possibilities that it appeared. So it's like flipping a coin. If I'm looking for heads, head appears once on a coin. There's a head and a tail side. So that's one, and there are two sides to the coin, head and tail. So half the time I expect to get heads. So apply that logic to these problems, and it makes sense. So in this case, I'm going to total the numbers, so the total of appearances, and then let me pull up my calculator here. So 122 divided by 572 is going to give me it's going to give me 0.21, but that needs to be a percent, so then that will be my final answer. 21% is my answer. Hopefully this makes sense. If you do have any questions, just see me in class and we can go from there.